Network is an interconnection of we just not separate mostly small separate mostly this is just what you call code program. Giving use execution control, the elder games, the procedures, and you can use different things. You can use source, distribution, agent, control, and that is what we do. Another important another very important view of provider usually network as a tool. DSS goes there is a tool DAS system, other system. DAS system is your data, and data communication.
Shall we start? Guys, shall we start? Guys, shall we start? Yeah, fine. Okay. So in the previous class, we just discussed about the second module. We just entered the second module. So second module tells us how to use the language support. That is, Verilog provides some support, and how to write a program, the correct syntax. For example, syntax means what you, if you just open your calculator and if you just give 1 plus 1, it will give is equal to, if you plus, it will give 2. If you just 1 plus 1 plus plus, and if you don't enter anything, there may be a chance that, or if the syntax is not fine, you will get a warning, syntax error. Syntax error. Similarly, any coding language, you need to follow this simple rule. We have to write the story the same script. For example, nowadays it is universal. You can watch any movie. If you have English subtitles, you can watch a French movie, you can watch a German movie. Fine, no problem. So if the English subtitles are absent, we have to just understand the what to say, the pictures. That's it. So what I mean to say is, if you want to learn coding, you need to follow the syntax. Syntax, if you write the syntax in a proper way, then only you can conquer the any programming language. Then only we can master the programming language. That is why the second chapter or the second module will give a lot of preference to writing a program. How to write a program in Verilog. So the various steps involved in writing a program are explained clearly in this particular module. So let us move straight away move with the lexical conventions. So these are the things we have discussed in previous class. White space. Verilog will ignore the white spaces. These are the things we have discussed in the previous class. Examples of comments. The operators. Yeah, fine. What do you mean by an operator? An operator is the one which performs a specific operation. For example, there are three types of operators in Verilog: unary operator, binary operator, and ternary operators. So unary means a single operator. For example, you can see here, a is equal to not of b. Not is a unary operator and b is the operator. So you can see that a is having a value which is derived from the negation sign. That is, negation is the operator and b is the operand. B is the operand. So you observe carefully. Initially, if b is equal to 0, what will be the value of a? Definitely 1, right? Not. B is 0, a is 1. If b is 1, a will be 0. So what I meant to say is, a unary operator is the one which will precede the operand. Direct. Unary operators precede the operand directly. Binary operators appear between two operands. If there are two operands, a is equal to b double ampersand c. So double ampersand is a binary operator. Means what? A binary operator is the one which have two operands. So two operands are B and C. The value of A depends on B and C. Similarly, ternary operator. Ternary operator is the one which will have A is equal to B question mark. Question mark is a question mark is and colon is the ternary operator. So let us try. Let us not waste much time on this type of operands. So we'll not use this type of operator. Just for your information sake, remember that there is ternary operator followed by question mark and is to. Question mark and is to. It's a ternary operator. So ternary operators have two separate operands that separates three operands. So you can see here ternary 1, 2, 3 operands are. Likewise, it is separated by question mark and colon. So we'll never use this operand in our discussion. So you can write the program in this way also. So these are the concept of operators. So then moving to the next part, lexical conventions, numbers. How to define numbers? Numbers are defined in the fashion. This is the format: size, tick. Tick is very important. Here, tick you are seeing this tick, right? Size, base format, number. So what is this base format? Base format is something but whether it is a hexadecimal number, whether it is a binary number, whether it is a octal number, whether it is a any other different base format. If you have different base format, the base formats will be you can just, if it is a hexadecimal number, you can just type H. If it is binary number, you can just type small p. Size is written only in the decimal. Size means 10. 10 means the number is 10 bit wide. 10 bit wide. Size is written only in decimal. Decimal specifies the number of decimal number. Base format, it can be decimal, it can be hexadecimal, it can be binary, or it can be octal. So you can see here binary. You can use small b or capital. Left to you guys. The numbers examples starting from 0 to depending upon the base form. Uppercase letters are legal for number specification. So you can either use a small b or capital B to represent the numbers. To represent the numbers. Are you getting guys? Are you able to follow guys? Reply me. Hello. Okay. So any number can be written in this example. So let us try to see some examples. So that examples will make the concept clear. So you can see the example. 4 tick binary number is 1111. Whether it's a valid number? Whether it's a valid number? Yes, definitely it's a valid number. Why? Because specifying the size 4 tick is the format to represent the number. 4 tick, the number is in binary. So can I use this number? 4 tick 4 tick binary 3333. Is this a valid number? Is this a valid number? No. Why? Because you cannot use 3 in binary. Only you can represent the number as zeros and ones. Whether this is a valid number? Is this a valid number? Guys, answer me. Yes, it is a valid number. Very good. How you will tell that it is a valid number? Because the size is same for tick 0101. Now, if I want to represent this, whether this is a valid number, no, answer me. Now I typed a number. Whether this is a valid number? No. Why? Because I have represented 3 and I've put 4 bits there. That's why it's a invalid number representation. Invalid number representation. So now you can see here 12 tick hexadecimal ABC. 12 tick hexadecimal ABC. Whether this is a valid number? Yes, it is a valid number. Why? Because 12 is the size A, B, C. If you want to represent it in terms of 4 binary, it will take size 12 bits only to represent the number. Now 16-bit number, 16 tick decimals 255. Yes, it is also a valid number. So let us try to see some illegal numbering. So it is about your size number. There are two types of number systems. One is your size numbers, other is your unsized numbers. Unsized numbers are specified without a base format. Specification are decimal numbers by default. Unsized numbers, no, we are only by default unsized numbers are decimals. Numbers that are written without a size specification have a default number of bits that is simulator and machine specific. Suppose you have a brand new laptop, the size is 64-bit. Suppose your old laptops or old desktops, it is 32. Nowadays, all machines, all the laptops are 64-bit processor. They are all able to process 64 bits. So that is why if a number is written without a size, it becomes unsized numbers. Unsized numbers. Examples of unsized numbers. Examples of unsized numbers. You can see it 2, 3, 4, 5, 6. This is a 32-bit decimal number by default. Why it is 32-bit? It is machine specific. Suppose if it is a new laptop, it will become 64-bit. Okay, it is machine specific. Okay, it is machine specific. Whether it's a valid number, tick hexi 3. Yes, it is also a valid number. Why? Because we are not specifying size. In the previous case, we have specified size. Here, it is an unsized number. So this way also you can reflect numbers in your program. So let us try to see the example of numbering in the actual programming. Just I'll share the simple program here in your chat box. I'll share the simple example. Just go through that example. How beautifully we can write numbers in verilog. Just a second. Give me a second. I'll just share the program. I'll just share a simple program. The program may look a bit lengthy. Don't worry, it's very simple, guys. Okay, do not panic. Verilog is easy. First, you keep that in mind. The program is a bit lengthy. Don't worry about the length of the program. All of you got the program in the chat, right? Just analyze the program now. So what is the module now? The module is 8 to 3 encoder. Encoder will do the operation of reducing the data or compressing the data, encoding the data. So what are the inputs here? Inputs are enable, A input, Y output. So you can see that you are trying to reduce the 8-bit data to 3-bit data. That is the main output, but that is the main. So I want to save my output. That's why I'm using a register here. And now look at the size specification also. Input 8 bits. How to define an input of 8 bits? Use the square braces. Use the square braces. 7:0. 7:0 means what? I'm starting from bit number 7 to bit number 0. How many bits are total? In total, it is 8 bits. Okay. Then you can see that three bits output. How to define 3 bits output? 2:0. Now I'll ask you a question. What about 4 bits output? So what about 4 bits representation? It is 3:0. 3:0. So now see here, just we have learned this thing. I'm assigning output as 3-tick binary 0, 0, 0. We just learned this convention in this class. Okay, just go through this program, guys. Just go through this program, guys. You'll find a lot of interesting things here. I've used the case statement here. Case, end case, end model. ಇದಲ್ಲದೆ ಬೇರೆ ಯಾವ್ದಾದ್ರು ಬಂದ್ರೆ default. It is XXX. Don't care. So just go through this program, write this program, take a pen and paper, try to note down this program, or try to analyze this program by yourself. Okay. Okay, I'll come back. This is how we can write the size numbers and unsized numbers. Now, I just told that I have to use XXX. So what is this, sir? What is X and all? Let us try to see the same thing. You just see here. Numbers are there. I hope you have got this number system. You have got how to represent numbers. All of you understood this? If you understood, I'll go forward, or otherwise I'll explain once again. All of you understood how to represent numbers? Speaker Katie, are you here in the meeting? Unmute yourself. Speaker. Speaker. Mega. Geeta. Afridi, are you able to follow?
Yes, sir.
Number system, how to represent numbers and all.
Sir, size and size base
format and then the number. Size followed by tick. Tick is very important here. The small one.
Tick base format.
Size, tick, base format, number.
Base number.
Yeah, number. Exactly. That's the point. Okay, if you guys follow it, I'll go further. Otherwise, I'll once again explain. Fine. Afridi, you can mute yourself. One second. Hello. Hello. Yeah, I'm back. If you're able to follow the number system, we'll go further. Okay, it's very simple. Size, the base format, size, tick, base format the number. Yeah. So then in this program we had a small x here, right? X. So what is this, or what is this? What is the meaning of ZZ? You use ZZ here and XXX here. How, what is the meaning of that? X or Z values. Verilog has two symbols for unknown and high impedance values along with zeros and ones. So along with zeros and ones, you have to deal with two more things here, X and Z. X means unknown. Output is unknown, or the input is having high impedance Z. Always, if you don't know the output, we'll represent it as X. If you are not sure about the input, we'll just represent it as Z. Yeah, these values are very important for modeling real circuits. An unknown value is generated by an X, and high impedance value is generated by Z. That is the meaning of X and Z in this program. That is the meaning of X and Z in this program. What is Z now? Z is high impedance. That is high impedance. X is unknown. X is unknown. Examples for X and Z. 12 tick hexadecimal 13x. This is a 12-bit hexadecimal number. 4 least significant bits are unknown. 1 is fine, 3 is fine. Remaining X means there are 4 least significant bits which are unknown. 6 tick hexadecimal X. This is a 6-bit hex number having 6 unknowns. 32 tick binary Z. It is a 32-bit high impedance number. This way you have to write the, you can use your X and Z. X is unknown, Z is high impedance. Negative numbers, yeah, definitely negative numbers can also be specified by just putting a minus sign before the sign, before the size for a constant number. Example I show you, -6 tick D3 means it's a 8-bit negative number stored as 2's complement of 3. Here you have to remember that size constants are always positive. It is illegal to have a minus sign before base format and number. So before base format it is illegal. So it is fine. -6 tick T3. So here it is illegal. You cannot use this. You cannot use this. You can specify the negative numbers also in Verilog. Note the sign of specifier which is optional. Here you can see here 6 tick SD3. What is S here? It is sign specifier. Or else, if you have to understand this, an optional sign specifier can be added for signed arithmetic. So you can optionally you can add S here. You can leave it, no problem. You just leave it. Don't confuse. Don't get confused. You can leave this yes. You can just write a negative number just by putting the minus sign in front of this. What to say? The size number. Before size, you have to put the negative sign. Then only the things will work. Otherwise, the program will show you an error. So copy this program. Copy this program. All of you copy this program that I have put in the chart. Program name is 823 encoder. 823 encoder. Copy this program. Is it visible to you guys, right? Okay, copy this. As soon as you copy, just tell me that it's done. Okay. Done with the copying of the program? Guys, finished copying? ಮಾತಾಡೋದಪ್ಪ ಈ ಕ್ಲಾಸ್ ಮಾತಾಡ್ರು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಮಾತಾಡ್ರಿ ಎಲ್ಲರೂ ಪುಟಾಸ್ ಅಂಡ್ ಪುಟೀಸ್ Sahim Balaro, who is this? Unmute yourself, Sahim.
Yes, sir.
Are you able to follow?
Yes, sir.
I have written the program.
Yes, sir.
Okay, well, you just tell me only yes, sir. You just talk with me now.
Okay, sir.
How are you feeling?
It's fine.
Fine. Okay then. Okay. Copy the program. Rohan ಯಾರು?
ಎಸ್ ಸರ್.
ಇದೀರಾ ರೋಹನ್?
ಹಾ ಸರ್ ಇದೀನಿ.
ಬರ್ಕೊಂಡ್ರ ಪ್ರೋಗ್ರಾಮ್?
ಹಾ ಬರ್ಕೊಂಡೆ ಸರ್.
ಅಸೈನ್ಮೆಂಟ್ ಯಾವ ಸಬ್ಮಿಟ್ ಮಾಡಿದ್ರ? ಸಬ್ಮಿಟ್ ಮಾಡಿಲ್ಲ ಒಳಗಡೆ ಅಸೈನ್ಮೆಂಟ್ಸ್. ಕ್ಲಾಸ್ ರೂಮಿಗೆ ಸಬ್ಮಿಟ್ ಮಾಡಕ್ ಹೇಳಿದ್ನಲ್ಲ. Okay then, fine. We'll stop here. The later things will continue in the next class. Put your name and yourself in the chat window. Thank you very much.